Okay, we'll start very basic. We're going to do a wrap 3 pull 2, which is in the category of the wrap and pull family of how we tie around anchors. Wrap and pulls are they're single point load distributing anchors. So single point load distributing anchors. Anytime we do that, my go-to is going to be some kind of a wrap and pull. Wrap 3 pull 2 is traditionally like the most well-known, easiest to understand, universally recognized. Easiest way to tie this is I'm going to take my object, in this case a tree, and I'm going to start with my overhand knot. I'm just going to pin it right at the tree or the object or whatever, and I'm just going to go completely around, and I just want to keep that frame of reference, or that reference point, that knot right on the tree. I'm going around 3 times. Since it's a wrap 3 pull 2, I can go around once, wrap 1 pull 1, which is just a sling. I could do a wrap 2 pull 1. I could do a wrap 2 pull 2, or even a wrap 3 pull 3. It all depends on my max expected loads and how strong I want my system to be. So that's 2 wraps. I still have it pinned, and I'll just do 1 more. Bring all this over. All right. So my ideal catenary angle, even with single point anchors, they have an internal catenary angle associated with them. And I want my internal angle to be between 30 to 90 degrees. And so what I'm going to do here, I'm going to tie my knot here, but I'm going to give myself a little bit of slack or distance here. And I'm going to tie the frost variation of a water knot, because I don't need all this stuff here. So I don't want to tie this huge anchor and have my focus extended way out. I want to operate close, because real estate is kind of precious in the rope rescue world. So I take a bite. I treat this bite as if it were the terminal end, so this eliminates the need for me to cut. And then I just start at the back end, not at the front end. If I start at the front end, I'm stuck and I have nowhere to go. So I'll start at the back end. I'm going to give myself enough tail to complete the knot. So that should be about right. And I'm just retracing over that initial overhand right there. Back out the end. So again, when I say load distributing, what I mean is that the resultant will find its own path, and it's free to do that, and we want that, especially in our single point anchors. That's what we want. So I've tied my knot. Now I'm just gonna pin that knot flat up against the tree, and then pull the rest. And so you can see the internal angle here. It's a little less than 90 right there. So that would be 90, a little bit less than 90. So I'm happy with that. It's close to my anchor. So I've reduced all this extra space that I would have foregone if I would have tied this sling to its full length, and then this would be extended way out, and I don't want that. Load distributing means whichever way the resultant force is going, it'll tend to equalize itself, just like this. This is really great, especially with our directional anchors in the pulley. We route a rope through the pulley, and we have an idea of where that resultant's going to go, but maybe we aren't completely sure. If we have a nice solid single point anchor, we want to do a wrap and pull every time, or a load distributing anchor every time. This is our go-to. I could easily just say this knot could easily be on the back end. It's only on the front end for inspection purposes, so that everybody can see what it is, but I can easily go thread this around and do a wrap 3 pull 3. And granted, the knot will see a little bit more tension, but not as much on the front. So let's just assume that I got that knot all the way around, and I can just grab all 3 strands, and that's a wrap 3 pull 3, plenty strong. I have 1, 2, 3, 4, 5, 6 strands of webbing at 4,000 pounds, and then I have to do the math on the internal catenary angle, but plenty of bomber. Again, I can do a wrap 1 pull 1 if my load's very light, wrap 2 pull 2, wrap 2 pull 1. My options are really just, I can go as high as I want to on this, but you really don't need to go beyond 3. So single point load distributing anchor with webbing. Okay, let's go to another single point off to the right over here. And what I've done is I kind of simulated a sling that's been tied, and this is called a basket hitch. And they're fine. There's nothing wrong with that. But it's not my go-to, because depending on the material and how many times I wrap this basket around, it can act as a load sharing with enough pull tension. If my resultant shifts, I load one strand while the strand over here goes slack, and vice versa, right? Here, well, since it's really smooth, I can probably finagle it, and it has these load distributing qualities, but it isn't always the case on every anchor. I don't want to tri-load my carabiner if I can avoid it if all possible. Not to say that this carabiner can't handle it, just wasn't designed for those kinds of directional forces. So whenever I do that in the basket, maybe I should consider using a tri-link instead. So tri-link when I'm doing this. Again, my go-to on the single point anchor is not going to be a load sharing basket. It's going to be those wrap and pulls, which are load distributing. So my primary is going to be wrap and pulls. My secondary, if for some reason I can't do a wrap and pull, my secondary is going to be maybe a basket of some type. If the angle, if the internal catenary angle can't handle this in a sling in my basket, maybe I'll consider using a choker or girth hitch. And the reason why, for me, that preference is down on the list is because even with a basket, you have 1, 2, 3, 4 strands. But when you do a choker or a girth hitch, and I'm going to slide this up just so you can see it if I have the distance. When you do a choker, a couple of things. First, granted, I would never want to extend out this far, but I only have 2 strands on the girth hitch. Second, if you zoom in and follow the strands back over here, I really have to be careful about how much I'm weakening my system here, especially when I start to crank this and cinch it and back on itself. This severely weakens the webbing when I do that. So I have to be really careful when I use girth hitches.